All right, I reread the question and now I realize what the error in my logic. I misread the question. I had misread it and I said, oh, there's 60 siblings. No, there are 60 sibling pairs. 60 sibling pairs. Pairs. So that means in each class so 60 sibling pairs, that means there are 120 siblings, but that tells us that in each class there aren't 30, there are 60 members of a sibling group, right? So let's go back through our logic again. Let's say I pick someone from the junior class first. What is the probability that I even pick someone from a sibling pair? Well, it's going to be 60 over 1,000, which is the same thing as 6 over 100, which is the same thing as 3 over 50, right? Fair enough. So there's a 3 in 50 chance that I pick someone who's a member of a sibling pair. Now, in order for me to have a complete sibling pair, when I go to the senior class and pick someone, I have to pick this junior sibling. And that junior only has one sibling in the senior class. So there's only a 1 in 800 chance that I pick their sibling. It doesn't matter that there are the other 59 siblings in that are useless because they're not this guy's sibling. So I have a 1 in 800 chance of doing that. And you multiply them, you get 3 over 40,000. And that's choice A. When you don't see your choice, make sure to read the question again. I'm almost out of space. Let me clear all of this. Let me clear all of that. And we're on problem 218. 218. Which of the following cannot be the median of the three positive integers x, y, and z? So the median, the middle number. They say, well, a is x. Well, no, that's not true. What if this was the order, x, y, z? Then x would be the median. So it's not a. B, z. No reason why z can't be the median. The order can be y, z, x. It's not B. C, x plus z. X plus z. Well, let's see. Could x plus z be the median? X plus z. Could that be the median? So let me think about it. If we have x, z, and y. I mean, by definition, one of these numbers have to be the median. We have three numbers. One of them has to be the middle number. Under what circumstances could x plus... I mean, if x plus z is the median, that implies that x plus z has to be... that neither x nor z is the median, right? Do they tell us that those are... Right, they're positive integers. None of these are 0. So, in order for x plus z to be the median, that tells us that neither x nor z is the median, right? And if neither x nor z is the median, then y has to be the median. And then that tells us that x plus z has to be equal to y. But if y is the median, the order is this, x, y, z. And there's no way that I can add x and z and get a smaller number than z because all of these numbers are positive. Right? Yeah, they say three positive integers. So I go with choice C. That cannot happen. The median cannot be x plus z. Problem 219. What is the 25th digit to the right of the decimal point in the decimal form of 6 over 11? Okay, whenever they ask you for something ridiculous, there must be some type of pattern we can exploit to figure out what the 25th digit is. So let's just start dividing. 11 goes into 6. We're going to have some decimals there. 11 goes into 60 5 times. 5 times 11 is 55. And then remainder 5. Then you go into 50. You get a 4. 4 times, I already see the pattern, 44. Oh, no, never mind. Wait, let me make sure that's right. 55. You get 50 remainder. 11 goes into 50. 4 times, you get 40. So then you get a 60. 11 goes into 60 5 times. And you repeat, so on and so forth. So I just want to make sure, let's see, the first digit to the right is 25. The second digit to the right is 4. The third digit to the right is 5. And so, we could keep going. The fourth digit to the right is 4. So every odd digit to the right of this is what? It's 5. So they want to know the 25th digit to the right, and that's an odd number, 25. So it has to be 5 as well. So that's choice C. Next question. Oh, I thought I had erased that. Okay. Question 220. 220. John and Mary were each paid X dollars in advance to do a certain job together. Fair enough. John worked on the job for 10 hours. So John worked 10 hours. And Mary worked 2 hours less than John. So Mary worked 8 hours. Right? John worked on the job for 10 hours and Mary worked 2 hours less than John. So she worked 8 hours. If Mary gave Y dollars of her payment so that they would have received the same hourly wage, what was the dollar amount in terms of Y that John was paid in advance? Okay, John and Mary were each paid X dollars in advance to do a certain job together. Okay, so how much money did they? So John got X dollars and Mary got X dollars. They both got X dollars, right? So if you think about it, let's ignore who did what, right? We had how many total hours of labor? We had 18 hours of labor. 18 hours of labor. And they were paid how many dollars? They were paid 2x dollars. So they were paid 2x. They were paid 2x dollars, right? For 18 hours of labor. So the average wage should be, you can kind of view it, the fair, per hourly wage should be, let's see, we can divide by 9. Get a 1 and you get a 9. You get x over 9 dollars per hour. What was x over 9 dollars per hour? That's the fair wage. Let me reread the question. If Mary gave John Y dollars of her payment so that they would have had the same hourly wage, what was the dollar amount in terms of Y that John was paid in advance? Actually, let's think of it this way. So Mary pays John. Let me ignore this. I just thought of a better way of doing it. So they were each paid X dollars in advance to do a certain job. John worked on the job for 10 hours, and Mary worked 2 hours less than John. If Mary paid John Y dollars of her payment so that they would have received the same hourly wage. So after Mary pays John Y, so that means John got a total of Y dollars, and Mary has paid Y dollars. So now John has X plus Y, and Mary has X minus Y dollars. And so if Mary paid of her payment so that they would receive the same hourly wage, what was the dollar amount in terms of Y that John was paid in advance? That John was paid in advance. So let me think about this a little bit. So they received the same hourly wage. So they essentially, Mary should have 8/10 the money of John, right? So X minus Y should be equal to 0.8 times X plus Y. Am I thinking about that right, or is there an easier way to think about it? Well, let's think about it this way. John worked 2 hours more than Mary, right? However, so Mary, essentially, if she pays him for 1 hour's, then if she, this is the right thing. X minus Y is equal to 0.8 times X plus Y, but I'm going to still end up with an X here. So you get X minus Y is equal to 0.8 X plus 0.8 Y, right? And all the logic here I just said is, well, Mary's total money, if we're going to be fair, should be 0.8 of John's total money because she worked 0.8 as much hours. And so let's see. Oh, actually, they want to know what John was paid in advance. So that's X. So they actually, okay, we're fine. So they just want to know what X is in terms of Y. So we're cool. So let's subtract 0.8X from both sides. So you get 0.2X minus Y is equal to 0.8Y. And then add Y to both sides. You get 0.2X is equal to 1.8Y. And then multiply both sides by 5. You get X is equal to, what is that? 5 times 18 is 50 plus 40. Add a decimal point, it's 90 is equal to 9Y. And that is choice E. I got a little confused with the wording of it when they say, what was the dollar amount in terms of Y that John was paid in advance? They should have said, what was X? And it would have been a little bit easier. Anyway, I'm all out of time. Sorry for bumbling through that problem. See you in the next video.